Hey, welcome to Hardware Asylum. In this video, we're going to be diving back into the Hardware Asylum Vault. As you may remember, the Vault is my hardware collection. These are boards that I've kept over the years. Some are review product from the 20 years that I've been running Ninja Lane and Hardware Asylum, and others are just ones that I've collected that I really like and wanted to hold on to. So let's go find the board. It is actually over here. Let's see. It's not that one. Oh, yes, it's in this box here. Bring this back over. Now, much like the other Hardware Asylum Vault video, the board in question is in a box that doesn't have the same board in it. This is an 8-bit box. And, okay, so it's not that board. It's, oh, it's right here. Get it out. Put this one back. This is a socket 5, by the way. We will cover that one in a future video. Now, of course, not all boards that are in my hardware collection are review product. This particular board is a 486 based on the AMD DX4 120. And strangely enough, this board came in a system that I acquired, as all my 486 machines prior to this had either been repurposed or sold. I think my last 486 was a AMD DX2 80 megahertz, which was kind of my favorite 486. And sadly, it was repurposed and sold as part of a network build for a local lawyer. To be honest, I don't remember how I got this motherboard. I do remember that it came as part of a build in a super awesome mini tower computer. It was I'll see if I can put a picture in, but basically it had the turbo button, the reset button, a toggle switch, and then also a little dashboard that had the LED display to do high and low turbo. And sadly, when I was cleaning the lab one time, all of my AT cases went away. But being a hardware nut, I disassembled them completely. I tore the machines down, basically flattened all the machines, and I took all the hardware out. When I started looking through the hardware vault, I was reminded of this 486 motherboard, and this might be one of the oldest pieces of hardware in the vault. Of course, all the hardware in the Hardware Asylum vault is special in some way. And of course, with a 486 machine, I've been reminded of my 80 megahertz box that got me gaming. That was what I was using to play Duke Nukem on. I tried to play Quake on it, but of course, it didn't really run very well. The interesting thing about the 486 in general is that it was a processor that existed during a huge change in the hardware world. So this was kind of a mid-release 486. It came with the 72-pin memory, the 30-pin memory. It still had the AT power socket. We have full ISA 16 slots, and we have the VL bus. Now, older 486s didn't have the VL bus extension. Later 486 boards had actual PCI slots, plus the ISAs. And as the 486 was kind of a generational change, it's important to understand why things had changed the way that they were. For instance, the VL bus was added primarily so that you could get faster video performance. ISA video was notoriously slow. Intel added the VL bus extension, which really became the PCI of the 486 generation. It did have some limitations though. The clock speed of the VL bus was only at 40 megahertz, which really limited what kind of 486s you could run. Depending on the speed, like for instance the DX4 120, it runs at a 40 megahertz frontside bus. This DX4 100 runs at a 33 megahertz frontside bus. And there were certain AMD processors that had a 50 megahertz frontside bus, which had incompatibilities with the VL bus extensions. You couldn't run cards, it would be unstable. And unfortunately, that really limited sales of those particular chips, despite them being architecturally superior to some of the chips that were out at the time. Most 486s are all jumper based. So we have a series of jumpers here that will set voltages, front side bus, how much cache is available, and just about everything that you would normally do in a BIOS now on a modern system. We have a Cmos chip here. These ones were likely EEPROMs. If you feel in the middle, you can feel a little circle. You might be able to see that in the reflection if I pull it up. But there's a circle there, and that is how you reset the EEPROM. Now, EEPROMs can only be programmed if you pull the chip out and put them into a programmer. They can't be flashed, much like a modern machine. Early 486s did not benefit from a level 2 cache, and on certain motherboards, the cache chips are actually fake. Now, if I was running something slower than a 120, the level 2 cache, regardless of how much was there, would not really increase performance at all. And I've looked around and I've been told that these cache modules are likely fake, but when we fire this board up, we'll find out for sure. I'd already talked about the memory performance. We have 72-pin SIMs and then 30-pin SIMs. The important thing to remember here is that on the 46 you can run a single 72-pin SIM module, and you just basically plug it into the bottom slot and then populate it. Reads from the bottom up or from the top down, depending on how the jumper is set. If you have 30-pin SIM memory, you need to install all 4 chips. That's just kind of a limitation of the architecture, and also how the memory was sold. The form factor is basically the baby AT, and you can tell the AT form factor by the single DIN connector for the keyboard and basically nothing else. This board is also a little bit more modern than some of the others because it did come with the CR232 battery holder. Normally this would be a barrel battery with a charge circuit and notoriously leaky acid issues. Here at the bottom we have the model number, which is AV8540, and if you look online, a lot of people complain about this particular board and some of its downfalls, despite it having a lot of really great features. Alright, to get these boards running, I like to set up a little test bench. For that, I have this aluminum plate. Basically, it has a bunch of standoffs that have been drilled into the board. I've had issues where once I get the board mounted to my plate, it doesn't want to boot. And I suspect that there's probably a short or something like that with a standoff touching a trace on the back of the motherboard. And during this generation, they would sell regularly with cases these little red washers. Maybe I'll put a picture in the video. But those red washers were designed to insulate the back of the board when you installed your standoffs. You would still get a ground off of the screw contacting the metal chunk on the top of the motherboard, but there were issues where that standoff might touch a trace on the back of the board, and that red washer was to insulate it. Now, I don't have a manual for this particular board, so I'm not sure what the jumpers do, and there isn't a map screened on the board itself, so, well, maybe the map is right here. But what we're going to do is we'll just populate all the sockets with memory, and then there won't be an issue. The way SIM memory installs, it goes in at an angle and you pull it back, and then the metal clips hold the back of the PCB in place. And because of how it is angled, you have to start on this side and go that way, otherwise you cannot get them installed. The trick is you want to get the memory seated good before you pull it back, and if it resists a little bit, move the metal tab. The last thing you want to have is a broken memory socket as something that you cannot replace. The VO bus was introduced to increase video performance, but card manufacturers started using it for just about everything, and hard drive controllers could really take advantage of the extra bandwidth. In this case, we can run 2 IDE controllers. For video, we're going to keep it simple. A Cirrus Logic GD5422. It's basically an ISA 16 video card. Powering these old 486 motherboards requires a special power supply, one that will deliver the 6x6 power plugs and has a negative 5-volt rail. The negative 5-volt rail went away once the ISA slots went away, so any modern power supply is not going to have that output. But if you pick something old, like we have this Antec True 430, we can see that we have a negative 5 rail. It only delivers 0.5 amps, but it should be enough to power on this system. Now we do have a 20-pin ATX connector, so we need to adapt it. And for that we have this little guy. It plugs into the 20-pin power connector and gives us 2 6x6s and a power switch. You need to be careful when you install these. The black wires need to go together. Now, of course, if you're putting one of these motherboards in a case, the case will likely have the power supply you need. But on the test bench, while I have AT power supplies, I find the adapter works really well. PS2 keyboards will work if you have the PS2 to AT adapter. Don't expect a USB keyboard to work in this instance. Now before we go too far, let's install our postcode reader and we'll see if we get any activity. That means that it's going to work. We have 2 more things to install. The first is storage. And while I do have IDE drives that will work on this, they are notoriously slow. So I'm going to use an SD card reader that has an adapter to an IDE interface. Basically we have a micro SD card here. Clicks in place and acts like any other hard drive. Thing to remember when you boot these machines up is that if you do have the cable installed incorrectly, the activity light will flash solid. It basically will just be on all the time. Power the system down, flip the cable, and it'll work just fine. That works also for floppy drives. The final item to add is a heatsink. Anything in the high-end DX2, DX4 range requires a heatsink. Strangely enough, these are just a friction fit that installs over top of the ceramic CPU. Detect our hard drive. Here we have our DX4-S CPU at 120 megahertz, counting up to 36 megs of memory. And it's testing it 3 times, it appears. It says here we have 256K of cache. Well, as expected, this board does have a set of fake memory cache. We see that level 1 and level 2 cache are represented here. However, this particular processor comes with 8 kilobits of level 1 cache on board on the chip itself. So what it's seeing is that we have 4 kilobits and 8 kilobits of cache, and it's testing both of them. but it is not reading the 256K cache of onboard memory. And per the research, the chips are soldered, and they're actually soldered in the right direction, they're right side up. Everything about them seems to be correct, except that they're not being reported. And in the BIOS, you can't disable it. It's always enabled. So that is really kind of leading me to believe that we got fake cache on this particular motherboard, which means that while I kept it because it's a 486, and it's pretty darn awesome to have a 486, it's not one of the better boards to have for this particular platform. So we've learned a lot of things by exploring the Hardware Asylum Vault. One is that this particular motherboard is really not that great. While it does have the AMD DX4 120 MHz processor and a VL bus enabled motherboard, the board itself is really not that great. We have fake cache, or what appears to be fake cache. It's soldered onto the board. We do have 72-pin memory support, plus the 30-pin SIM memory support, and again the VL bus, which is something that I really like about 486 boards, is that they were the only ones that came with the VL bus. But later editions of the 486, which really supported more of the AMD processors, came with PCI slots. Intel, of course, was moving towards the Pentium, which was socket 5, and all the Pentium boards came with PCI slots on them. And they didn't release much in terms of 486 beyond the 100 megahertz over here, although I believe there was a 120 megahertz. And then, of course, AMD released 133 and a much higher front side bus, really just adding a lot more performance to the entire platform, getting a little bit more use out of the socket 3. And that really concludes what I'll be doing with this 486 system, although there is a lot more that can be done. I mean, we can swap processors, we can enhance the cache over here because this is really the only board that's going to allow it. Or we can actually find another board that has the PCI Express, swap these processors around and see what kind of overclocking performance we can get out of them. If you have questions or comments or want to see more from this, leave them down in the comments below. And as always, like, comment, subscribe. And thanks for watching.